And we'll come to your shortcut approach, Will, in a second. But Anthony, you just said it. Is you just start from scratch. In other words, you write out your hypotheses. You write your little pictures, and you say, okay, my guess is, I don't know, 2 and 7, or my guess might be 3 and 6, and you calculate the thing, and it probably won't come out to 20%. Then you pick another pair of numbers, and eventually, if you keep picking pairs of numbers by 3 or 4 iterations, it doesn't take more than 3 or 4 usually, and that should take about 20 minutes. You're going to get the proper pair of boundaries that comes out to 20%. And then once you have that, you take the 3.8, and let's say it comes out to, I don't know, 3 and 6, for argument's sake. It happens to be close to 3 and 6. And if a 3.8 is in between 3 and 6, is 3.8 in between 3 and 6? Then you would say accept A0. If you have different numbers, everybody's having different numbers. So that's how you do it. So that's good, and I owe you a piece of paper. But that turns out to be very tedious. It takes 20 minutes to do a lousy example, and you want to be able to show, because we don't really, trial and error is never really the best approach. So Will suggested the following shortcut. Will said, since eventually we're going to go from the population picture to the X-bar picture to the Z picture, let's eliminate those other pictures and go straight to the Z picture. The Z picture has to have, if it's going to have the proper 20%, what percentage has to be here? 10, and this has to be 10. Right? Then what you do is you go to the back of the table and you look up which particular Z number chops off 10%. Now, what Z number chops off 10%? Let's do it right now. For those of you who are following my suggestion of bringing a table to class, look up 10% right now. What is that Z number? That it turns out that, yes, Nakia. Very good. It comes out to, you know that by heart? Whoa. Okay, so the right answer is 1, because we did the same exact thing for 80% confidence in the previous chapter, so some of you guys should know it by heart, but that's very good. So 1.28. So I owe you one of those, Nakia, thank you. I owe somebody else some, you said something a few minutes ago. I'm going to take one of those. So 1.28, I'm not even going to bother, well, let's write it down. So the magic number here is minus 1.28, or if you look up minus 1.29, it's sort of in between. And then what do? What's the next thing? Yes. You have a formula that relates the Z to the X bar. Now, what is the Z number you're going to plug into that formula? 1.28. What's the X bar? Well, the X bar is the unknown. That represents the boundary that we're looking for. What's the mu going to be? Well, the mu is the hypothesized 4.5. What is the sigma of X bar? Well, that's the sigma over n from chapter 7. 1.2. So everything is plugged in. The fact that this is 1.28, and that's just a coincidence. They're nothing to do with each other. So you solve the equation. That's not I'm solving this little equation with one unknown is not a big deal. And then you get your boundary. And once you get your boundary, then check to see if 3.8 is inside or outside the boundary. So the whole thing, instead of taking you 20 minutes, might take you 2 minutes. But it turns out there's another shortcut that will, instead of 2 minutes, you get it down to 20 seconds, where you don't even have to solve any equations. And I'll show you that again on Monday. I said I wasn't going to show it to you now, but for those who want to do homework 35, this might save you another few minutes. Anybody can understand what the next shortcut's going to be? Where you don't have to solve any equation. Well, again, since we only have minus 1 minute, I'll say it quickly, is you just take your X bar, which is 3.8 in this particular example, that group's numbers, minus the mu divided by the sigma, and get a number. But we already know that the boundary in terms of Z numbers is plus or minus 1.28. So all you got to do is check to see if that number, which is not, if you're not solving an equation, just plugging numbers into a calculator. If that number is in between plus or minus 1.28, what do you say? Well, you're not supposed to, we accept the A0. But if the number X bar is really far from 4.5, so you end up with a pretty big positive or negative number here, you end up out here, then you say reject A0. So in essence, which I'm going to show you again on Monday, but we're going to finish the whole chapter on Monday because now you have the whole idea. We're going to do 4 steps to solve every hypothesis problem. We're going to write out the hypotheses. That's just formality. Then we're going to take our data, plug it into this formula to come up with a Z number. Then we're going to take the alpha that we're given, chop it in half, look it up on a Z table to produce the plus or minus 1.28. And the last step, which is the easiest but the most important step, is you take that number from the Z calculation and compare it to the Z table and see which side of the boundary are you on. So the whole thing takes 20 seconds or a minute at most. So please do it any way you want, the long way, the short way, William's suggestion of solving an equation, whatever way you got, but at least show me you tried this between now and Monday. That's the only homework I'm going to be checking.